All right, we're gonna go back over a few things here. This is what I like to call the quantum dollar. So three men walk into a hotel room, and they each pay $10, and so it's a total of $30 for the room. Then they go up to the room, and the guy at the front desk goes, "Wait a minute, I've overcharged. The room's only $25." He gives the $5 to the bellhop. Bellhop goes up to the room, and on the way up there, he's like, "There's only three guys, so I'm going to pocket $2. I'm going to give them each $1." And so he goes up there, gives them each their $1. Now they've each paid $9 apiece. So 3 times 9 is 27, plus the $2 in his pocket, 28, 29. There's a missing dollar. I've just mathematically proved that a dollar has a 1 in 30 chance of hopping dimensions. Mathematical fact. You guys know, I just said, right? There's 3 times 9, they each paid $9. 3 times 9 is 27. That's a mathematical fact. Add 2 more, that is 29. That's also a mathematical fact. The truth of the matter is I haven't proved anything. What I've done is just done the math wrong, because math by itself does not prove anything. It is only the way in which you map the math to reality that is really, really important. So my point here is just, once again, that there is a lot of interpretation that people believe is not necessarily there in our physical theories. Then there was also, I wanted to kind of still get into kind of the history. There was a movement that sort of happened around the time of, so first we started with Einstein's idea that there was no, that we didn't, well, it wasn't necessarily Einstein's idea, which we kind of covered, but there was the idea that there was no ether, yet there was still waves. So if you could have waves without any medium, and then we went into quantum mechanics, and then we said, well, we can also have probability just exist by itself. And so if you can have waves without probability, waves without a medium, then you can have probability without events, right? And so you can see this kind of going towards where they're getting very, we'll use the word creative in physics in their interpretations. And once again, the one thing I'd like to say at the beginning of each and every one of these is the idea that mathematics is like a crystal, and interpretation is like light entering a crystal, and that is, when I shine the light on the crystal doesn't change, but the angle that I shine the light on the crystal can change what comes out the other side. And so that is the importance of interpretation when it comes to mathematics and physics, etc. So along with one thing, which was the shut up and calculate movement. Whenever anyone said this is irrational, it makes no sense, they tell them to shut up and calculate. The other direction that also went in physics was really spearheaded by Paul Dirac. There are many different quotes of this kind that you can find, but these are the ones I like to pull out. These are two different ones. I should have separated them somehow, but the result is too beautiful to be false. It is more important to have beauty in one's equations than to have them fit experiment. Does that sound like a scientific statement to anyone who has experience in science? It shouldn't. And then I learned to distrust all physical concepts as a basis for a theory. Instead, one should put one's trust in a mathematical scheme, even if the scheme does not appear at first sight to be connected with physics. One should concentrate on getting interesting mathematics. So one of the things that, you know what, I wonder if I put his quote in here. Here we go. This is an excellent quote to follow that up. This is from Nikola Tesla. Today's scientists have substituted mathematics for experiments. They wander off through equation after equation and eventually build a structure which has no relation to reality. The scientists from Franklin and Morse were clear thinkers that did not produce erroneous theories. The scientists of today think deeply instead of clearly. One must be sane to think clearly, but one can think deeply and be quite insane. And so that is what he was referring to, is that there was a level of insanity that was taking over the community of physics in their interpretation. He wasn't saying that the mathematics were wrong. He was saying the way that we were looking at what we were getting, they were going off in the wrong direction on their ideas of how they interpreted the evidence. And then, of course, by the time we got to beauty in physics, they no longer cared about evidence. They started to believe mathematics was this pure thing that could be relied on and trusted 100%. But as I demonstrated earlier, it is so easy to go wrong with the tool when you're not mapping the tool properly. It's that connection between the two. The universe is not made out of mathematics. Mathematics is a useful tool for analogy, and there's a connection between the analogy and what it represents, the tool and the representation. That is something that's overlooked too frequently. Okay, so we're going to get into, that's right, a lot of this, we're still going to be pretty technical because I want to talk about some of the things that, some of the other things in modern science right now that are a little bit weird. And I like to call this dark magics because there are a variety of Nobel Prize winners who have called dark matter fairy dust. That's it's one of the things that they tend to call it because right now our current belief about reality is that 0.4% of the universe that we see is stars. Another 3.6% is gas. And then we've got 22% dark matter and 74% dark energy. So that is all things made of atoms. So a lot of people don't understand that the idea of dark matter is not that there's some unknown matter out there that we haven't seen, but it's this other thing that's undetectable. It's magic is what it is, and that's why we're talking about. I should have picked one of the Nobel Prize winners' quotes for this specifically, with them calling it, magical thinking and fairy dust, etc. But I didn't have that immediately. Yes.
Is it FM or AM?
What do you mean?
Fucking magic or alternative magic?
Yes, it's a good question. So I was going to tell you a little bit about what dark matter was. Okay, what dark matter was, the discovery of dark matter was actually experimental falsification of general relativity. And that is, general relativity is supposed to predict how gravity works and how things are rotating around each other, and how the speed at which something rotates around something else is very, very directly what general relativity is supposed to be telling us. So when we looked out to the stars and said, okay, let's compare it to what this theory says and see what are the stars actually doing. And they looked out to the stars and saw what they're actually doing. They were doing something wildly different than what general relativity predicted. And instead of saying, oh, that's called experimental falsification, we instead say, no, there's magical fairy dust we'll never actually be able to detect or know what it is. It's just basically fairies. And understanding that that was where we went is crucial, and understanding how it was that we were getting to this point of magical thinking in science and accepting these ideas that were created because there was this idea that, hey, revolution is great. We love this idea of revolution. We're going to do things a new way. That's a great idea, but it can go too far. So basically you have the vast majority of the universe. All of this is exactly the amount of stuff required to make general relativity work. That's what dark matter and dark energy are. Is when we look out to the universe and we see what it's doing, for general relativity to be correct, we're going to add all this stuff we can't see. So that's how bad off it is. But they don't tell you that. They just tell you there's this much of this magic stuff and that much of that magic stuff. And this is just within our solar system. General relativity works very well for a small system like the solar system. You hear these are the inner planets. There's Jupiter, Saturn, probably Uranus or something.
So what we need is a new
way of looking at things.
Equation to cover that carries the counts for that.
Right. Okay. Oh, I think it's doing the slow thing. Oh, anybody who's been here before knows about the slow thing. Okay.
At least once per.
Yes, at least maybe, and it's going to be a few times in this one, unfortunately. All right. This is something called the Kuhn cycle. Thomas Kuhn was very well known. I don't know what epoch he was known very well in, but he's known for the structure of scientific revolutions. And
70s, 80s.
Okay, and so it was very. He did a fantastic job of describing something that I believe personally, because we're very speculative today, I'm going to jump around towards very speculative and creative things. I think that what he described is actually part of the cycle of life. It's a part of the cycle of discovery. It's a part of the cycle of everything. I think that revolution is, and the cycle that is required of revolution is kind of the cycle that happens in the development of life itself. We do the specialization thing, which eventually makes an organism or an individual or anything or any complex system. It makes it become obsolete over time, but specialization is necessary. So therefore revolution must come in. It's one of the questions of why is it that certain organisms die at a given age? What's that set point? Because we've been seeing that it's not necessary for an organism to die necessarily. Matter of fact, there's something called the immortal jellyfish that all it does is it does this cycle purposefully to make sure that it can live forever. And that is, so normal science is the activity which most scientists inevitably spend most of their time. It is predicated on the assumption that the scientific community knows what the world is like. Normal science offers often suppresses fundamental novelties because they are necessarily subversive of its basic commitments. As a puzzle-solving activity, normal science does not aim at novelties of fact or theory. When successful, finds none. Now, people really loved this guy when he was out at first, and now that we're getting to this thing where we're doing this declaring science is done, we've found the God particle, we've done it all. We have done this over and over, people. In science, we have repeatedly said, we did it all, we're done. We don't have to worry about it anymore. We've got it all under control, and we're always wrong, we're always embarrassingly wrong. So he basically, in seeing how science has progressed in the past, talked about this. We had normal science, which is where you have to pick. Normal science is a necessity. You must specialize. You have to believe in something to be able to explore that something. You have to basically have some sort of faith. You have to put a stake in the ground and you have to explore around it to find out if it's true. You have to be able to test something, especially when it's complex. There has to be something to believe first. And that's the necessity of your normal science, is that it is sitting there and it's looking for everything around it. But eventually, as we find little errors here and there, little things that went wrong in this way and that way, the model begins to drift. We begin to add all these exceptions like dark matter and energy, and well, this little patch over here and this little fix over there. And the funny thing is how much this works in the software development cycle too. The exact same thing happens. And then model crisis. Then you start running into problems where this doesn't work with this, and it will never work with this. And it's like, we'll just look around that because we got all this stuff that's working. If it ain't broke, don't fix it, and it's working right now. Don't touch it. Don't touch it. Then eventually we get to model revolution and the paradigm change, and it goes all over again. Okay, so this is just some different things that show how we've got fluid mechanics explaining cosmology, and dark matter being problematic, and the vast structure of galaxies discovered in the Milky Way's components spell trouble for dark matter. There is a lot of things going on kind of under the surface out there that you don't necessarily, you have to kind of be picking through the science to see that there is a somewhat mainstream recognition of that there is this fluid model that that could work instead of what we're doing, and that there is a problem with dark matter, even though whenever you it seems like when you first are touching on the surface that the whole idea of dark matter, it's all solved, we've got it, we're all in lockstep. That's not true. Then also, standard model of particle physics. You've got problems that are coming up where there's a flaw in standard model as well. So at the quantum level, we're running into problems, and we're seeing that our model does not work. And then they always want to act like, oh no, it's small. No, there are big gaps. Like for instance, the fact that the model doesn't actually account for gravity, along with it just not really working. Is this the end of physics as we know it? Is this the end? Is this the end of coal? The end of the world? No. So where do we go now? And that is, we have some areas of development that have been promising in the analogies that they provide. For instance, and these fields are they're exploratory, so they're very active. They're still expecting things to not go the way that they expect per se. So in other words, they're still in that we're really learning here. We don't know. They're not as confident, I suppose, is the best way to put it. They are less confident in what it is that they know and what it is that they don't know, and that is specifically in plasma physics and fluid dynamics. So it's not some one-off field, but rich with lots of specialists. So this is what I'm trying to show you here, is that there is a revolution that is literally on its way, and people don't necessarily recognize the revolution is right. We're right at the cusp of it, and it's currently occurring. But it's difficult to recognize when a revolution is happening because it's everybody doing their own little thing, and it comes together as an emergence. So it works on big problems. It's been applied to cosmology on a large scale. It's integral to nuclear physics on a small scale, with plasma physics especially, and actually plasma physics are kind of there's applications at both scales. But there is not one big rigorous theory of everything that anyone's put together with these things. There's individuals working towards their own goals, but nobody has put together one big thing that everybody could even really, get their arms around and start, tearing apart, because that's what you're supposed to do. It's like, okay, you put this out there. The community won't allow something like that to really get out without, first of all, either punishing somebody who's an academic or just ridiculing somebody who's on the outside of academia. If you're on the outside like I am, at least I can look like an idiot. It's fine. That's not going to ruin my career. But an academic who this is their specialty, they can't really start putting anything that's very radically different out there, because they'll be seen as a kook. They'll be labeled as a kook. They'll be ostracized. They'll lose funding in their other projects. It's a very dangerous territory. But what I'm trying to do, and hoping actually I've been seeing a tremendous amount of progress with, is that the community is starting to change. People are starting to see we've got this revolution that's happening in psychology. We got a lot of screw ups there. We thought we're all good, and now we're seeing that we're having to go back over all of our studies there. Oh, now it's starting to happen in biology. Too much interference from pharmaceutical companies, and now it's starting to happen a little bit in physics right now. People are beginning to doubt. They're saying, maybe, I don't know. There's a little bit of problems here. Maybe we shouldn't be so confident as we were. Okay, so equations were based on inviscid fluid dynamics. Lord Kelvin actually began to work on something called the ring vortex atom model. Except that the ring vortex atoms were strangled in their crib because he was actually a very big proponent of relativity. He was, I think, was it Lord Kelvin that actually did the expedition to the North Pole? He might have been the one. He's got two names. He's Lord Kelvin and like another name. I don't know. I don't understand that British stuff. But then there's addition to that, there was Fresnel's index of refraction that we use today, just like Maxwell's equations. We still use them today. They're based on inviscid fluid dynamics. Fresnel's index of refraction used today was a calculation created to describe ether. What he was doing was he was talking about, he projected that ether would be carried along to a certain extent. And the index of refraction that we use today, developed by Fresnel, was originally called the coefficient of ether drag. It's the same thing, two different names. And then Lorentz's transforms, as we talked about earlier in one of the other presentations, was a mathematical description of the effects of ether on light. So all of these things, you see the ether's been there the whole time. It's just nobody's paying attention. It's just going, hey, I'm over here, and they're not paying attention. So and then from filamentary arrangements of galaxies to frame dragging effects, everything works as fluids. So here's some interesting, plasmas in space. One of the things that we see is something created by Hannes Alfvén, I think is how to pronounce his name. I don't know. I just read it. I don't hear it. So what he discovered is there's these interesting effects with plasmas, and we see these effects happening on the sun. You can see first, that's his experiment top left. Right beside it is one of these what are they called?
Solar flares?
Say again?
Solar flares?
Yeah, but no, that's not just a solar flare.
Plasma.
It's I've suddenly forgotten. That's one of the things, by the way. If you're a person who's into stuff, a lot of times they might call you a mad scientist. I forget the names of things, very common things. It happens all the time. It's really weird. So I forget what these are called, but these coils of plasma flows are found in the sun. They're found, this is deep in space. We find them on the Earth. That right there is up at the top once again. You see the blue picture. That is where solar flares are happening. At the edges of what we see are these plasma flows that happen on the sun. And then down here on the Earth, the actual trade winds seem to be driven by these plasma flows that happen within the magnetosphere of the Earth. And now the two pictures all the way to the right look very, very similar, but they're actually, one of them is basically the magnetosphere of the sun, whereas the other is the one of the Earth. And in both cases, what we have is these effects of plasmas from outside beating against a magnetic shield that's created by the magnetic field of a large body. We're actually inside the sun's large field, and we have our own little field inside that. And so who's to say that, well, actually it's pretty obvious, galaxies have the same thing going on, and you have this sort of a fractal effect. So, dark energy, expansion, or just the Compton effect. So, one of the ways that we have decided that the Earth, the idea of the Big Bang and all of these things came from Hubble's discovery of redshift. And that is that when you look out, you see that the light is shifted. Now, what we've got over here is there's particular lines within this spectrum that identify different elements. And when you're looking at light coming from something that is going the same speed as you, you'll see it in one place. But all of the lines will shift in one direction or the other if it's moving at a very significant rate away or towards you. This is the Doppler effect. However, there is another effect that does this. Now, initially they disregarded, like whenever you're looking at the sun as it begins to set, it turns redder because of dust in the atmosphere and things like that. That is one kind of shift that occurs, and a kind of redshift that occurs. But the way that it occurs, these lines end up different spaces apart. Little things like weirdness like that happen. So you can differentiate it from the Doppler effect. However, in Compton scattering, what occurs is all of them are equally shifted, they are redshifted specifically equally, so that you cannot tell the difference between something moving away from you and the Compton effect. So if light travels through plasma, it gets redshifted. Now, one of the things that we find when we look out and we see this idea that where dark energy is as well, the universe is expanding. Not only is it expanding, it's expanding at a faster and faster rate the further you get away from us. And it's exactly equal in all directions. When you look in every direction, you see it's all redshifted. And it's all shifted by the same amount depending on...
Because we're the center of the universe, like the church says. I mean, wait, no.
and so, and now they
The other church said before, we're looping again.
About how, well, it just kind of looks that way. But the truth of the matter is there's a much easier explanation, and that is we know that there is plasma all throughout space. What's causing our magnetosphere to constantly be moving, and I mean, we have our magnetosphere looks like kind of like a comet because of the pressure of the plasma that's coming off the sun, and it's moving it around, and there's just tons of plasma coming off the sun. And then we've got, as I showed you before, there's also that bow shock thing around our entire solar system, because there is a difference between what is inside our little bubble and what is on the outside, and if it is an electromagnetic effect, then the best guess that we have would be that there's more plasma out there, which means that there's tons of plasma all throughout the universe, which means that if we know the Compton effect occurs, then why don't we think it's this instead of this? Well, it's because of the first thing that occurred to them, and there's a level of fame, and sometimes just things take on a mind of their own. They just, and as a matter of fact, I should have done my homework and figured out when Compton scattering was best understood, because this may have not been. There's a difference between it being understood and it being understood by everybody. Living in the information age, we are at a point where we have such easy access to everything. It's kind of hard to understand that people had to communicate via letters. They didn't even necessarily live in towns where they could meet with each other. And the periods of time that it took for information to travel around was just immense compared to now. So this may have even been discovered before this by a long shot, but maybe Hubble didn't know about this, and maybe a lot of his friends didn't know about this. Maybe this wasn't really well understood, and so this idea stuck. And now we have this really obvious explanation that it's like, well, so how much are you, how much are you dealing with the Compton effect? Because it has to be occurring, period. We know there's plasma there, and you can't find anything about that. So they're not dealing with it, is the point. So the idea is that, there is the possibility that we have a steady state universe, by the way, is what I am trying to get at here. Now there's another thing in plasma physics that is not really well known, and that is something called plasma vortex crystals. And that is two-dimensional studies, which means basically you're looking at, there's a border on each side. That's the difference between two-dimensional vortices and three-dimensional. They end up turning into toroids. So they like a vortex, instead of being like a tornado, which is from one border to another border, the ground and the clouds, that's two-dimensional. Then you've got a vortex that wraps around itself and becomes a donut, and that's would be three-dimensional. So whenever they're studying two-dimensional vortices in plasma, all they need to do is just spin it up, and then it turns into these things. These things end up with these very regular patterns that automatically arise simply by the nature of turbulence in plasma. So, if you're looking at these things, you should see hints that these things look a tremendous amount like galaxies, but then they start to have properties of atoms. They crystalline solids, things that make up the base levels of our reality. And so we see these interesting behaviors in plasma, and I will, like I said, once again, I'm trying to break slowly away from just purely science and get a little more speculative here. And it's interesting to say that perhaps what's going on. You know what? I need a drink. Hold on. Give me just a second. So there is something I touched upon yesterday, and that is something called wave-vortex duality. And that is when you have waves in an area, underneath them are vortices. And so this is something that people who just play around with stuff call cymatics. And they're like, ooh, look at these neat patterns. But ooh, these neat patterns end up showing us behaviors, which if you'll watch this right here, let me restart this real quick. Let's see if I can do that. Let's watch this one right down here. What you've got is a vortex here and a vortex here, and then another one right here in this direction, and another one right here. So in 3 dimensions, there are these complex vortices that are all interlocking with each other. And then the outcome is these very regular shapes, and it's based upon a combination of amplitude and frequency. And then all throughout here, what you'll just see is whenever people are playing with various frequencies, you get things that look like a chromosome or something like that. You get all of these various effects that are basically emergent properties of fluids. But then, what I wanted to briefly cover was the idea of solid, liquid, gas, plasma, and ether is kind of like the ancient idea of earth, air, fire, water, and spirit. It used to be called the upper air that the gods breathe. And so when you're talking about authoring, fun steampunk stuff, getting into the idea that there was once a very technological civilization that once existed on the earth, there is a lot of very interesting little tidbits all throughout history that can be used to suggest that perhaps we had information that we lost, and now we're simply regaining it. So this is Saturn, and on Saturn there is a constant hexagon that's always there. I don't know how many people are familiar with the hexagon on Saturn, but there's suggestions that what it is caused by is this same effect, the cymatics. It's been there for as long as we've been observing it. It's I guess it's been a little over 30 years that we've been observing it, and so it's a very stable feature. And the explanations of it, once again, have to get into a combination of waves and vortexes. And you can see the waves here, the light is actually being refracted a little bit, and you can see the waves that are left over as it came to a stop there. So once again, I'm just kind of getting into this idea that the ether and wave-vortex duality, all of these things kind of go together, and there's a lot of evidence behind it that suggests it's an area of study we should be paying attention to. Now, here is when I spoke about Lord Kelvin's ring vortex atom. So this is a very well-known scientist. He wasn't just kind of, there's always a bit of spitballing, in any kind of theory building. But his idea was that perhaps what's occurring is these ideas of toroids. Now, a toroid or a torus is just a vortex that is like a donut that's just kind of spinning in on itself. And what's interesting about that, and something I used to bring to some of my talks, would be one of those vortex launchers. I could shoot it across the room and hit somebody, you could knock somebody's hat off across the room. Because what's interesting about the torus is that it's able to keep the energy inside itself better. There's something in fluid mechanics called big whirls lead to little whirls, which feed on their velocity, and little whirls lead to smaller whirls and on to viscosity. And it's just this this idea of what happens with vortices and with turbulence and the study of fluids. So ring to vortex atoms actually didn't go away. It just got all of the idea of it being an explanation for atoms shaved off of it, and knot theory is what is left of it. Knot theory is actually an extension of Lord Kelvin's idea of ring vortex atoms, and it's still studied in universities, everywhere today, because it gives us some very interesting results and usages. So here's some of the the basics. This, matter of fact, this might have been a drawing that I've seen this one so many times. I'm guessing Lord Kelvin might have drawn this one. And here's some other ideas of what these things look like. And so if you think of it as this circulation of fluid, you can kind of see how this would be these ideas of this right here is sort of a Mobius strip, and then these are just more complex Mobius strips. Here's where they're studying in a tank, where they're launching toroids out, and what you have here is a vortex filament that goes throughout it, and they've actually been able to create some interesting, trefoil knots. Okay, now let's talk about superfluids. So superfluids are something that is only very recently been understood. And we're finding out more new stuff about it. It's weird stuff. So helium, my contact who actually writes these papers tried to get me to remember the difference between helium-2 and helium-3, and I don't remember. But so there is slightly a difference between which ones do the best, vortex filaments, etc. But I'm just going to tell you, helium-3, 4, one of those, the superfluids, they have interesting behaviors, and one of them is, for instance, that in they'll just crawl right along borders. Like, in other words, you take this cup, put it down in the fluid will actually go over and start filling up the cup to where they're level. The other thing that they have, these vortex filaments that start throughout there. Now, this looks like I've just copied something from one of my other slides. You see, once again, these regular crystalline figures, but this is actually, once again, this is the behavior of superfluids. So you see an analogy between plasma physics and superfluids. And now here, this is an idea. Once again, you see the trefoil knot here. This is an idea of what you would see in space everywhere if space itself is a superfluid, and that is all these little vortex filaments. Now this is a little bit better because I like this one because it looks a lot more like neurons. I'm going to get to that in just a second, probably. So this is just another one of the vortex filaments. It's just showing you how helium-3 starts with one, and then it can turn into additional ones, and you have more and more of them. This is just showing what a vortex filament is. It's a rotation. It becomes very thin and long. So what does all this mean? I guess I haven't gotten there yet, but I'm going to tie it all together. I swear I will. I know I'm leading you guys all over the place. You're going, man, my head's about to explode. I'm hoping for that. So this is Louis Breuil. He says, I have come to support wholeheartedly a hypothesis proposed by Bowman and Vigier. I don't know, I'm probably butchering that. According to this hypothesis, the random perturbations to which the particle would be constantly subjected, and which would have the probability of presence in terms of wave function wave, arise from the interaction of the particle with the subquantic medium, which escapes our observation, is an entirely chaotic, and which is everywhere present in what we call empty space. So going back to yesterday's presentation a little bit, this is the idea that we have these particles that are pulsating in space. And what are they? Well, they are made up of the fluid that they are bouncing in. In other words, there's nothing but the fluid. The fluid is the only thing. The ether is the only thing. Here, once again, you have the droplet walking around in the corral, and it matches predictions of quantum mechanics when it comes to the fact that there's a probability of finding it in any one particular place that is a wave function. So to try to conceive of what this would all mean, I want you to think of the idea that matter is the thing that is more ephemeral. It is the thing that is like bubbles in the ether. And the ether is the solid. The thing that we think of as empty space is the most rigid thing in the universe. And what we are and what everything is made of is not really made of stuff. It's a borderline where that stuff is no longer, where at the very center of a given atom would be a vacuum of ether where there is no ether. And that the areas around an atom are basically these complex knots that are swirling around the atom, because what it is it's a flywheel. Is anybody familiar with the idea of a flywheel? If you set a wheel in motion, it continues to retain that energy. So what you have is three-dimensional flywheels around these vacuum cavitations that are bouncing and able to keep within them the energy of motion that is occurring. And it is because why they show these behaviors is because they are there is this wave vortex duality that is occurring in every single particle. What I'm showing over here on the left is that's a cavitation that's occurring in a fluid. And so is this, of course. What's occurring here is not just gas coming out, which we'll let it go again. You see the gas ends about right here. This is cavitation. And that is that the material cannot stay together as fast as it can rip apart before it slams back together and turns inside out, and it creates here a very chaotic pattern. But if that pattern was extremely if it was fractal, if it had a structure which could keep from breaking apart in viscosity, if you could keep from turning into those little whirls that drain off the energy into the surrounding fluid, then it would be able to do that for a much longer period of time and become a stable entity like an atom. So, let me talk about solid-luminescence for just one moment. So over here on the left, when you pump a fluid, and this is just water, when you pump a fluid with enough energy, eventually it will begin to cavitate. And then as it slams back together, it gives off light. So that is the conversion of the mechanical energy of the pressure of the fluid into another type of energy. And so this would be these cavitations are giving off some energy. And as we know, particles do tend to give off some sort of energy. They give off waves. All right. Then the other thing that it's talking about here is Bernoulli's principle. So, and this is where I'm trying to represent what exactly an atom would be. The structure that's required. Yes.
Are you an hour or 2 hours?
1 hour. Is there another one after this one?
No.
Okay. To show you here, this is Romanesco broccoli. I don't know if anybody's familiar with it, but it's a good representation of fractals found throughout nature. And what I want you to imagine is that what is occurring in an atom is, as the cavitation occurs around it, the fluids, because it's such a hard substance, it can't act like a normal fluid. It has to move, it has to be spun around. It has torque that it has to deal with. That's what we find in waves that occur in solids instead of in fluids. In fluids, they have what's the kind of wave? There's transverse and there's longitudinal waves. But in the ether, what we find is light is a transverse wave. So basically, it has to torque sideways for the pressure to move around through it. So what's occurring is as the cavitation rips open around it, forms these structures that are like gears going against each other, and they turn they go outwards in a fractal motion. Like I said, once again, I'm trying to get very creative here because nobody's ever really done this. And so I'm just trying to provide something that is a model of how it could occur, what could be happening here. Now there are some papers, like I said, that do get into the physics of it. With Ross Anderson, is one of the people who provides a paper, but he doesn't go quite this far as in how this would occur in something that behaves like a solid, and the ether behaves like a solid. And then the idea of what would be a wave then. Why do we have this wave-particle duality that occurs in waves. I've told you about particles, that they're turning in on themselves. Their energy is contained in an area, and it's a wave that's turned itself into basically an infinite loop, which is why I would say, if you want to connect this with sci-fi, why the infinity symbol is what it is. You saw it there in knot theory, and it works for fluids, and so therefore the infinity symbol is actually a description of the hydrogen atom, and so is the yin-yang. So here, what's happening with a wave? So here we have let's imagine that along this line is a vortex filament. So what you have is a very thin, drawn-out vortex, and they're existing all throughout space. Then as a wave comes by, what would happen is it would be changing the pressure locally. So if it changed the pressure locally, what would have to happen is it would have to spin up, and then it would open up a space. And so a particle that is occurring with waves is dependent upon the local vortex filaments. And so, since the ether is actually moving past us at all times, and it's actually caught up with the Earth's magnetosphere, it is moving past us by a speed which was detected by the Michelson-Morley experiment, and tens of thousands of experiments done by Dayton Miller. And that is a speed of around 10 kilometers per second instead of the 33 kilometers per second that they expected. And so, as a wave propagates along any given vortex filament, it opens up. And that is very close to a description of quantum mechanical particles that we have right now. So why is it that they would seem to show a different location at different times? I suspect that there is a pressure along the lateral part of a wave. So if you have a pressure built up along the lateral part of a wave, one of the things that happens, like as they go through a barrier, they tend to wrap around it because they're entering a place that has less pressure in it. It has less resistance. So the waves that were plane waves turn into circular waves as they exit a small area. So this indicates to me that there is a pressure that's lateral to the wave. So the changes that we might see, you can actually give up the energy of the pressure that's in a wave to a single location, and thereby lose some of the amplitude of the wave in the sides, along the lateral part of the wave. I hope I'm not. Yes.
No, you're talking about the double slit experiment, right?
Yes, I'm talking about the double slit experiment. How is it that they could get one single particle out of it, and why is it that it would appear the way that it is? And what I'm telling you is that it's just waves. And then when it interacts with these vortex filaments, then what is occurring is that at any given moment, the alignment of vortex filaments with a given wave would concentrate energy, which is just the mechanical pressure
of the slit.
Or motion itself is basically the essence of energy. Then it's going to resolve on a single place on a plate. So I did just briefly get into this before, which is the idea of gravity being based upon Bernoulli's principle, and that is that you have as a fluid speeds up, you end up having lower pressure but higher speed, and those things are kind of tied together. That's how an airfoil works on a wing. You make it go slower in one direction, faster in another, and you have a pressure differential, and that lifts the plane. So this also works with, the best analogy would be this rotating thing, which is a ball. Somebody throws a curved ball. What's happening is that you've got greater velocity of air and higher air pressure in one place than another, and so therefore the ball moves in a direction that's based upon spin. So now if you have these, now the best thing, if you want to have the idea of what a particle really would be, is that inside a given particle area, you have multiple vortexes going in various directions. Like you saw in that one droplet I had that was moving up and down, I was trying to point out the internal vortices. But from the outside, if you just look at the outside of that, all you see is the external toroid. It's just moving like this apparently, but inside it's got these other vortexes. So the point is that it's not going to be a very simply resolved model, but you will see these differences in pressure that occur around particles, and that, of course, would make things be brought together like you can just blow some air between two ping pong balls, and they'll be drawn together. And so this is an analogy for gravity that would occur in this ether-based model. So a new era is about to be born, and it all hinges on the ether. science. Sometimes 2 steps forward require 1 step back. And now I do have one more slide if anybody wants to go really into La La Land. And that is, I've actually published a paper on the way in which an ether-based revolution, when we get there, what that will mean for our understanding of neuroscience and therefore the idea of spirituality. And that is the one that goes quite far afield, but the idea is that is anybody, let me ask you,
It's not unsupported by,
no, it's not unsupported certainly by,
I wouldn't call it La La
then
Land,
I'm going
but
all
it's
the way
definitely
into neuroscience.
Yeah,
And,
it's-
and that's a whole other field.
you're going far afield for sure.
Right. So does anybody have any questions right now? Good. Who here would like to go even further? So I said this is mad science. All right, let's do it.
It's Mad Science Day.
So I actually pulled something from one of my other presentations I did at the Foundations of Mind conference in Birkeland, and that is from De Broglie-Bohm to Bowman-Pribram's model for consciousness, and that is what happens in the brain is that there's a model of consciousness that was developed by Bowman-Pribram, and you remember that I mentioned the De Broglie-Bohm interpretation is the pilot wave interpretation. So this is the same Bohm who was part of pilot wave that also participated in a model for consciousness. Thank you. And this model was the Bowman-Pribram model, and it's called the holonomic brain theory. And now, to understand what this means, the holography, as most people think of it, is not the projection of an image that isn't.
Save us, Leia, you're our only hope.
Right, everybody thinks of that as a hologram, but holography is more about the addition of waves, and we've been talking about waves in this series. It is the way in which waves add together. And one of the reasons, like for instance, when you look at a screen, that is, it has all these pixels, individual pixels on it that you're looking at. Each one of those pixels, there's a particular light coming from that place that goes all the way to your eye. However, when you're looking at a hologram, what is occurring? And there's not a particular color per se in one little place. What occurs instead is that the surface is altered in a way that causes light to go at various angles and for it to be mixed in the air. So in other words, when it reaches you, it's one color. You may be looking at the exact same place, and you move to another place, and it's a different color because the way that the waves add in the air. So this is what holography sort of is. Now another analogy I want to give you that'll help with going. I know right now I'm going very far, and it's like, why are you going in this direction? It'll all make sense in just a moment. And that is, if you think of the way that a record works, a record needle cuts into a surface, and the actual waves that you're producing with sound, if you're talking to an old style record, as it's cutting into the surface, it actually creates bumps that are just the same as the sounds coming out of your mouth. And so then when it plays back, all that it does is you have a duller needle basically that rides those bumps that have been cut into that surface. So that's how it replays it. Now, I won't get into some of the other things that turn it back into sound. Let's just leave it at that. But if I were to then take that where it's already got voices recorded and then cut into it again, in other words, set it up to record again over it, then what would happen would be an addition of the waves that are there and the new waves that are coming in. And it'd be something different. And this is actually how a little bit of the way that neural networks work, is that it is kind of an addition of
An average?
The information is being put over itself over and over and over. And that's what's occurring in neural networks in current neural network technology. So, and neural network technology, of course, is based upon the brain. So, in the Bowman-Pribram model, the idea is that neurons, when they fire, there's something called the right-hand rule. And as electricity travels down a wire, you have vortex around it. You have a magnetic field that is spinning in one direction around that wire. Now, if you have two wires together, one of the things that will happen is they'll tend to twist around each other. For instance, just like you saw with those whatever they were, the plasma vortices. So, and the thing is, when two wires are fired near each other simultaneously, there are waves that are going in each direction add together. And so one of the things that's very important to consciousness is for brain patterns to line up. And that is for various neurons to be firing simultaneously. It's not one neuron firing to the next that is important. It's the fact that there are numerous neurons that are firing simultaneously that are important. And that pattern, interestingly enough, is actually stored in the astroglia. Now, for the longest time, we didn't know that the glia were cells that actually participated in brain function, but recently we've been understanding how much they do. There's something called gap junctions, which causes glia to change their magnetic charge at a rate that is much slower than the brain waves that we have. So what a brain wave is in the Bowman-Pergram model is it's caused by the synchronization of firing. And that synchronized firing, then you have, if you were to think of it like the waves are going across towards each other, because you've got these individual neurons all firing simultaneously. When they fire simultaneously, they then create a pattern that is traveling along with it. And when that pattern is traveling along with it, there's going to be white space. So in other words, for instance, when you have, if I were to have three resonators in place on the surface of water, and had them going all at the same time, you'd see it rise up in the center, because then all the waves would interact with each other at the center. It would be the highest in the center, so there's almost like a white space right there. So there's something there that is just the combination of the firing. Well, it turns out that as the synchronized firing patterns occur in the brain, the astroglia then store that signal temporarily, and then from there, dendrites are actually drawn towards these points that are these magnetic interactions of places, so that your thoughts, which are basically the numerous neurons firing simultaneously, impinge upon areas in the astroglia, and then those places are actually places that the dendrites will follow and basically write a pattern of what that wave, that addition of those waves that came through, will actually write that more permanently into your brain with dendrites. So, if we're looking at space, and we see in it these filaments that branch, and the way in which they branch could actually be impacted by waves going nearby, then is there not a medium that is storing information? If we look at the fact that the placement of these chairs in this room are a type of information, and if we had the right way of reading that information, it could represent numerous things. And so there is a storage of information that happens in the brain, and happens in a very particular way that could be described as holographic. That is, you're writing the signal over something over and over and over. Every time that the brain waves fire in a specific pattern, the pattern itself is altered. So it's read and write simultaneously in one operation. Every time that you think of things, as you think about them more, the pattern is strengthened, and there are more dendrites that create a specific pattern. And it's only because they're firing in a particular pattern that you create these extremely complex waves that can be at various angles. And that's why we have these various sets of brain waves, different frequencies of brain waves that are associated with different states of mind and with different thoughts, and how our brains do work entirely based on electromagnetism. We can alter your morality by simply putting a electromagnetic device over the right temporal parietal cortex. You'll go from believing that it's the thought that counts versus a no harm, no foul in tests of morality, etc. So all throughout our study of the brain, we've been able to find that different places that were altered and changed and eliminated changed the way that a person behaved right down to their morality, to the very basis of who they are. However, when we look at this model, that we have all of these patterns of electromagnetism that is following the microtubules in the brain, which, by the way, I didn't mention, that the dendrites, the way in which they interact with those places in the astroglia and makes them follow along are these microtubules. These microtubules are little things that are basically like wires. And so those wires are basically like the filaments in the ether. And so there is significant reason to believe that perhaps we are storing absolutely everything that happens in the ether, because after all, we are not what is the hard thing. We are not the solid thing. We are an effect of the ether. What makes us is everything that's occurring around us. We are not the funnel of the, we look at ourselves, we see the funnel of the tornado, but that is not our full self. That is not our full being. Our full being and our full existence is all of the events that added together to make us, and not just those events, but the simultaneous events that are happening elsewhere are taking part in who we become and who we are in a fuller sense. So, let me see if I've got anything else here. No, that's just the point is to see that there is an analog way of storing data and processing data that happens in the brain that could be occurring in free space, and there's significant reason to believe that it is occurring in free space, and so therefore it's impossible for us to not be interacting with that field in one manner or another, and I think it's a worthwhile investigation to see if we are in fact recording our brains into the ether, if there is in fact an Akashic record that is storing absolutely everything that has ever happened, because it is also simultaneously making everything that is happening. Is there any other questions? All right, did I make everyone insane? I was hoping to. That's the idea. It's mad science here. And so I wanted you to leave here changed. Thank you. That's it. All right. Thank you very much. So the principles of space that we are. Let's assume that there is what exists everywhere outside of the world exists everywhere. Because if we're just a bubble of ether,
Did a couple panels. I was going to go check out later.
we are just the absence of the actual universe. I would think that also is if you were to turn it inside out enough, you could look at it from a perspective that says
Yeah, some people park over here and they're shutting because it's like, oh, you get to sleep parking or somewhere.
Oh,
I don't know, it seems
yeah,
like
there's, I found a meter. It's not, it's for themselves.
to jive with the idea of God.
That's what
Yeah,
I was talking earlier in the day.
it does with a whole lot of things.
Everything's taken out.
Yeah, I had to circle twice before I found one.
Take what you will, it's part of the fun.
Where can I find something?